To solve this radical equation, the very first step we need to do is make sure we isolate the radical. So I need to move this -2 to the other side, so we're going to add 2 to both sides. So on the left-hand side, I have the third root of quantity x squared plus 4, and that's equal to 2. Now that the root is isolated, we need to get rid of the root completely. So because this is the third root, the opposite of taking the third root of something is raising it to the third power. If we raise the left side to the third power, we have to raise the right side to the third power. So on the left side, we're just left with the x squared plus 4, and on the right side, 2 to the third is 8. So now we're solving for x, and we're going to be isolating x by subtracting 4 from both sides. So I'm left with x squared is equal to 4. And lastly, the opposite of squaring something is square rooting. So I take the square root of both sides, and I get x is equal to plus or minus 2. So we do have to check for extraneous solutions. So we're going to check x equals positive 2, and then we're going to check x equals negative 2. So we're going to be plugging in positive 2 into the original equation here and making sure we get a true statement. So it's the third root of, and we're plugging in 2 for x, so 2 squared plus 4, and then minus 2 must be equal to 0. So underneath this third root, 2 squared is 4, plus 4 more is 8. So I have the third root of 8. So the third root of 8 is 2, and 2 minus 2 is equal to 0. So positive 2 is a solution. Now let's check negative 2. So if I plug in negative 2 in for x, I would have the third root of quantity negative 2 squared plus 4, and then subtract 2 from that, and it should be equal to 0. So we will get a true statement because negative 2 squared is 4. So we're back to the third root of 8, right? And then we're subtracting 2 from that, which is equal to 0. So we don't have any extraneous solutions here. The solutions are plus or minus 2.